Hi, I'm Ryan Rhodes, and I'll be talking about Dr. Ramashandan's book, Phantoms in the Brain. I'm in Group 1 for Bill Greiser's class, and I'll be focusing on who Dr. Ramashandan is, kind of the experimental methods for neuroscience, and his contributions to neuroscience as well. So let me pull up my PowerPoint. All right, so Dr. Ramashandan is known as the Marco Polo of neuroscience. He's been named top 100 most influential people by Time magazine, published over 180 scholarly journal articles, featured on TED Talks, PBS 1 Hour specials, BBC radio, film, and actually Phantoms in the Brain was named, Phantoms of the Brain was named, or not named, was made into a documentary which we'll be showing on Tuesday. So it's really interesting because you get to see the dynamic of him with his patients, and the reason why he's been so successful with his patients is because the empathy and he has a very fun personality, very humoristic. You can read it in his book as well. So Dr. Ramashandan, he was born in 1951 in India. He got his PhD from College of Trinity, University of Cambridge, and then became assistant professor at University of San Diego, and then became head professor. And then his first research was actually in perception, using psychophysical methods to draw clear inferences about the brain mechanisms underlying visual processing. So Dr. Ramashandan, before phantom limb pain, was focused more on the visual processing. And actually in the book, my favorite ones were the cortical pathways, the people who were having hallucinations, the one lady who could see the cartoons, and then the guy who could see the delusions that he said were realer than life. They looked out of place, but he could see them. So I think he said there was a monkey in his lap when he was talking to Dr. Ramashandan. So Dr. Ramashandan, in the early 1990s, that's when he began focusing on like phantom limb pain, the neurological syndromes, body integration identity disorder, Capgras delusions, which Capgras was the man who thought his parents were imposters. He knew their look was right, but because the emotional connection wasn't there, he didn't believe that was his real parents. He's also had synthesia, understanding synthesia, if I can say it. And he also invented, of course, the mirror box, helping cure phantom limb pain in some cases. He was the first one to amputate a phantom limb. So synthesia I actually wanted to talk about because I thought it was super interesting. When he was looking at synthesias, he was looking at them kind of exploring modules in the brain. But synthesia is actually happens in like a real low population of people, but they can taste letters, hear shapes, or see numbers as colors. And then he goes over in his book, he's had some experiments and some theories on religion and where it's shaped. I think he talks about a guy who had epileptic seizures in the temporal lobe, and that's when God started talking to him. He had further studies on this. They didn't really conclude to anything. He didn't really shape anything from it. He showed or he would have religious words or religious pictures, as well as like normal pictures, and he would read like EEG readings in the brain and whatever was more active. He was trying to figure out like kind of a Marxist view where religion is structure. So more as temporal lobe is that thing to be like compliant structure, what keeps us structured in society. So let's go over the like kind of the experimental side and the kind of what different studies there are. So there's observational studies and then experimental studies. And in the observational studies, you have the cohort study, which is for research purposes, cohorts in groups of people who are linked in some ways and then followed over time. So you could say the phantom limb pain, different patients, and then they used the mirror box. And I think over 4 weeks, one of the guys was able to get rid of his phantom limb. It disappeared besides the fingertips that were still in his shoulder. So then you have the case control study, which also falls under observational studies. Here the researchers are existing records to identify people with certain health problems. A similar group without the problem is the control. So the cases, and then you have the control for the case studies, which is usually what you do is a case study. Then you have the experimental studies, which is randomized controlled trial, which is usually what they do with one group receives the drug or the treatment, and then the control group, of course, is either inactive or receives a placebo. And then you have the controlled clinical trial. So you have the randomized controlled trial with the two groups, and then you have the controlled. So remember, randomized, that one receives, one doesn't, and then the other one, it's kind of a bias, the controlled clinical trial, because the people get similar qualities ended up in each group, which could influence final results from that. And then qualitative and quantitative data. So the difference with, I explain these because where neuroscience is in its, like Dr. Ramaswamy says, is in its infancy stage. So a lot of this stuff and the findings that come out, they're qualitative data, which deals with like descriptions, data that can be observed that not measured, and of course quantitative, which can be measured, height, area, volume, anything like that. And because it's in its kind of qualitative state, Dr. Ramaswamy likes to look at individual studies and then build on like a population or a sample with case studies. So he uses the example, he has a lot of examples. He uses, I think, Galileo and the telescope, and then one of the ones that I liked that he used the example of is the magnet one with Fairfield. So Michael Fairfield, he did the magnetic one. Dr. Ramaswamy's very supportive of simplistic experiments. So he likes to use simplistic experiments. He goes into great detail about different professors being able to, the fruit smell of a diabetic for their breath, being able to diagnose someone with Parkinson's by just listening to the sound of their footsteps, and things, the nail beds for like nail clubbing can actually show like inflammation in the bowel, cardiovascular disease, liver disease, or AIDS, just by looking at fingernails. So he was always about, people always challenged him now that, hey, in Aristotle's day, yeah, you could use simplistic stuff to make great findings, but today you have to use the technology that we have to make these huge findings. And in the video, you actually get to see him. He works with, I think his name is Bill in the video, but he's able to find the remapping of Bill's left arm on his face. And then they go, and I think they do MRI, I believe it's MRI, not fMRI, where they actually find the remapping in his brain, where it actually shows on this side, it's a red and yellow area, which shows, and then for his face, and then his right arm, right side, left to right, and then on the right side, he has the whole red area covers also the area of where his left arm would be, showing he was able to find it on the remapping with the simplistic, I use it to clean my ears, but whatever those things are called, find the remapping and then able to show it with technology. So Dr. Ramaswamy, with his simplicities, was able to make huge findings in neuroscience, curing phantom limb pains, and then also he's using some of the things in the 18th and 19th century that were more philosophies, now being able to set up experiments and prove those. So he brings up Freud a lot, and Freud, when you talk about neuroscience, you're talking about the brain, you have to talk about self and the consciousness, and actually phantom limb pain is one of those. So like Freud would say, that's a defense mechanism because you lost an arm, you had that huge accident. Defense mechanisms end up being the phantom limb pain. So you're unconscious in a force to accommodate because of the bewilderment of one's body denial. So you could also say that Freud talks about repression. So Dr. Ramaswamy, he's been known for his crazy experiments and mysteries, but he does like Sherlock Holmes. So I kind of see him as they said he's a Marco Polo of neuroscience, but also kind of like the Sherlock Holmes. I think he actually quotes him right before chapter 2, and he says, "My dear Watson, the game is afoot." And so he kind of takes on neuroscience as that. He's been also known for his The mirror neurons I touched on a little bit, but his interest in autism, mirror neurons, and mapping certain areas of the brain, not trying to look for necessarily cures in certain things, but actually looking for like the how and what pathways and where it happens, and making that not just a location, but a holistic approach, and just kind of understanding the brain and self. All right, that's all I have for the first couple of chapters and who Dr. Ramashandan is. Hope you took something from it. I didn't stutter or say too much, and I'll see you on Tuesday. Thank you.